Well, hello, people of calculus, to coin what Mrs. Yo used to say back in your biology class. I have a new skill I want you to learn, and I think it would be much better if we did it through video. So I'm trying this to see if it works, and if it causes too much trouble, then we will try a different mode. But I thought this was something that you would need to see done live, in a manner of speaking. So, hello, and I hope you all are doing well. Today we're going to learn one last method of integration called integration by parts. We'll do some today, and then I'll model a few others another day. So you'll have two homeworks dealing with this. If you have problems, you only need to contact me either through Teams chat or through email, and I'll be happy to try to help you. So, integration by parts. You can see it on the screen. I've got it written out so you can see the big idea. I've written out the theorem from the textbook. We're not going to think a whole lot about the details, but this is a kind of a different method of integrating. It's not the first thing you would go to. All right, the other methods that we've done are a little bit easier, so you would try them first and then try this if you can't use other methods. The idea is that, see, I have a cursor here. If I have the integral of two values, u and dv, then these are equal to the value u times the value v. Now remember, over on the left side we have dv. This is u times v on the right side. Subtract the integral of v times du. Now this looks a little bit messy, and we're not going to use any really complicated problems with this, but I want you to be familiar with it in case you run across it when you're in college. Yes, I know you are saying you will never do this in college. Never say never. All right. Now, I have a space here for a couple of notes, and I will fill those in, but I think it would be better if I just talked about our first example first and apply it to what we've got written up here. So I have example 1. I want to take the integral of x times e raised to the x power times dx. And I'm going to solve this using integration by parts. What I need to do is I need to look at this product, and I need to label part of it as u and part of it as dv. Now, a couple of things to keep in mind. The part that's u is usually the easier part. And I'm going to write this up here under note. So, u is usually the simpler part. Now, if I look here at my example, I have x times e to the x. And if we look at this, in general, we would say that x is an easier part than e to the x. And so in example 1, what we're going to do is we're going to say that u equals x, and dv is all the rest of the product. So that would be e raised to the x times dx. I'll also put in under note doesn't apply to this problem, but it will show up later on, that you might want to consider that dv probably, let's see, how would we word this? dv should be the part that is easier to integrate. And that becomes very important because there are a great many things that are not easy to integrate, and sometimes they are impossible to integrate. So these are two different things to keep in mind. You can start by saying, well, I'll let U be the simple part. Or if you look and say, oh, I can't integrate this part that's dv, then maybe you need to switch them around and have the more complicated looking part being U. It just kind of depends. Sometimes you have to play around a little bit with it. So let me raise our problem up a little bit so we have some room. Alright, so I'm walking through this example. I have let you know that we're going to call U is going to be the x. dv is the entire rest of the problem. E to the x times dx. Now, the next thing that we need to do is we need to differentiate the u. And this should not be a very hard thing here. du equals dx. Okay, we can't leave it as just 1. It has to be 1 dx, kind of like what we've done on substitution when we're doing integration by substitution. Alright, so we need to differentiate the u, but then we need to integrate the v, this dv part here. Now, the good news is that when we're talking about this one, we know that the integral of e to the x is e to the x. And let me clean this v up. This program does not like making things with a point. Alright, so we have calculated what du is, and we've calculated what v is. This is our scratch work. So now what we're going to do is we're going to move over here, and we are going to substitute in according to the equation that is up here at the top. So this is equal to u times v. We said over here on the right that u equals x. So x times the v part is our e to the x. Subtract the integral of v, which is e to the x, times du. You go over here, and we said that du equals dx. So at this stage of the game, we are not quite done. But if we look here, the integral of e to the x dx is, well, it's just e to the x. So I can finish this problem by saying this is x times e to the x minus e to the x. And then remember, anytime we take the integral like this, we're going to have a constant. And this is the solution to example 1. And I'll even mark that in red. Now, you can ask the question, why did we have to do this by parts? Well, if we look over at the original problem, when we ordinarily take the integral of e to the x, we have to take the derivative of the x up in the exponent place. But look, we've got the x down here. This is not just your average integral. And this is because it doesn't fit into any of the patterns that we've used before, substitution. This is why we have to resort to using integration by parts. And I'm going to leave the answer to example 1 just like this. So again, the steps that we had to do is we had to pick out part of the integral for being our u. We had to pick part of it for being v. And then we plugged in, according to this equation, u times v minus the integral of v du. I have another example. Let me bring it up here. All right, there's example 2. Give us some space here. Example 2. We'll put it right there. Okay. Now in this case, we have the integral of x squared times the natural log of x times dx. And let's turn that into black. Okay, so in order to use this strategy, we need a u part and we need a dv part. In this case, I'm going to call my u x squared. Now, you can try doing it the other way if you want, and say that x squared dx is your dv part. That's legal. Well, let's actually try that. So, I mean, one way to look at it here is to say this is x squared. And then this part here is the natural log of x dx. But let's look at this, though. I'll leave the u for a minute, but if I put a dv in here, I'm going to have to integrate this. Now, have we ever integrated the natural log of x dx? No, we have not. So if I don't know how to integrate this, perhaps it would be better to switch them and put the natural log of x over here and put x squared dx on this side. Now, I know how to differentiate the natural log of x, and I also know how to integrate x cubed dx using the power rule. And I'll make that too just a little bit clearer. So, if I want du here, I'm going to skip a line there, make it look better. So du equals 1 over x dx. Over here I'm going to integrate. And using my power rule, that's going to be x cubed okay, and ordinarily if we were to integrate and take the antiderivative, we would put a plus c here, but we're not going to use the plus c in this part right here, so I'm not going to write it. Alright, so I have integrated my dv, and I have differentiated my u, and now I'm going to come over here, and I'm going to follow the formula. And the formula goes, the integral of u dv equals u v minus the integral of v times du. It's not quite voodoo there after that integral sign. All right, so that gives me the natural log of x times x cubed over 3, subtract the integral of x cubed over 3 times 1 over x dx. All right, we're going to have to do a little bit of simplifying here, I think. So let me work this out. This first product here, I can kind of make that look a little bit nicer. X cubed times the natural log of x all over 3. Subtract the integral. Now, looking here, it looks to me like I can cancel an x. And this is going to give me, let's see, I can also take the 1/3 out. So let's go ahead and do that. Times 1/3 times the integral. Now I'm canceling out an x, so it'll give me x squared dx. And again, this is something we can integrate. So last step here, x cubed x cubed times the natural log of x divided by 3 minus 1/3. Now we know that when we take the integral of x squared dx, we're using the power rule again. So this is going to give us x cubed over 3, and then this time, because this is right at our final step, we're going to put plus c in here. Now, the last step here is just to kind of clean this up a little bit. My first term looks really good. X cubed times the natural log of x, all that over 3, minus, now this next term here, I'm going to multiply the 3's in the denominator. That's going to give me x cubed over 9 plus c. And that is our final answer. Now, in this case, we chose our u and our v because we looked at the natural log of x and said, I can't integrate that. So I put it as a u, so I would have to differentiate it. With the dv, I knew how to integrate x squared dx. So that's, in that situation, that is how I chose what's u and what's v. Now, I have one final problem for you. And the final problem for you to try is to take the integral of the natural log of x, all of that over the quantity x, multiply that and I think I wrote that wrong. I think that should be x squared. Alright, so we'll do that. Yes. Alright, natural log of x over x squared times dx. Now, remember, we can write that, it might be handy to remember, that you can write this as the natural log of x times 1 over x squared times dx. Alright, so I'm going to wait about 5 seconds, and during this what you can do is pause the recording, try and work this out. Pick out what's u, what's dv. Work it out, see what you get, and in about 5 seconds of my time, what I'm going to do is I'm going to show you the solution. So I'm pausing now, and you go ahead and pause the video and go ahead and click play when you have worked through it. All right, for the u-try problem, here is the solution. Again, pick that your u is the natural log of x. For dv, even though it's 1 over x squared times dx, it would be easier to put this in the form of a power rule type thing where you have x to the -2, because then you can apply the power rule very easily and in order to find your v. And then down here, u times v looks like this, and then v times du looks like this, and then we start simplifying things up. And I will tell you that v times du is not always the same as what we had over here. Just something to keep in mind. But in this case, things came out pretty easy for this last integral. And so for our solution, we have negative the natural log of x over x minus 1 over x plus c as the solution. All right, now you're ready to go on to the homework, and good luck. Please let me know if you have questions. And goodbye, and have a good week.